Your OpenAI bill is climbing, but you have no idea which component is actually responsible for burning tokens. You've got your billing dashboard, your usage reports, but nothing actually connects the dots between this is how much we spent last month and this is the code responsible. So in this video, I'm going to walk you through the OpenAI billing structure and show you exactly what model usage, batching, prompt caching actually mean for your bill, and a solution to reducing your spend without compromising your code output quality or your engineering team. I think it's important to start by just understanding exactly how OpenAI is billing you in the first place. They don't charge by request or by time, they charge by token count, and that's broken down into input and output tokens. Input tokens being tokens you feed the model, output tokens being tokens the model gives back. And every model tier has a different price per respective token. For example, GPT-5 costs about 10 times more than GPT-5 mini. You can absolutely use the OpenAI dashboard to track your usage by model, by tokens, by the day, right? That's no sweat. Where it gets a little sticky is that doesn't always show you exactly where those tokens are going, right? Which function or component is actually making those calls. So it's really easy to lose track. Another place we see a lot of teams lose track and overspend is with outdated models. So for example, you pick the best, most appropriate model at the time of launch, and then months go by and you never revisit. So you're paying significantly more money, even though newer, more efficient, cheaper models are coming out. Especially for simple stuff like classification, summarization, data extraction, mini models are more than capable of handling those sorts of tasks. So you absolutely don't need to be paying a premium, especially for older models, when mini model capabilities are expanding as time goes on too. So we've seen teams pay up to 10 times more for capabilities they don't need, and that is hard coded into their code base with zero version management or evaluation. So it presents a really huge opportunity for savings in itself. Making sure you have the right tool for the task is obviously very important, but we've found other opportunities for savings in optimizing how many tokens you're sending and receiving overall. There are a couple considerations, but the first one we'll talk about is batching, which is exactly as it sounds, where you send more than one request per call. This winds up being a lot cheaper per token, often 25 to 50% less expensive per input token. However, it's slower. It adds a bunch of latency because requests are being processed in the background. So this isn't ideal for things where response time is important. It's fantastic, however, for bulk processing, log summarization, or anything asynchronous, like I said, where response time is not important. The next thing we'll talk about is prompt caching, where think of it like OpenAI actually saves your context. Like it'll cache your system prompts or detailed instructions, things you use often, and it'll save you up to 90% on input tokens, which is fantastic. This is not ideal if your instructions change frequently or if your system prompt is variable, things like that. Fantastic, however, for RAG applications, things where the context stays exactly the same across multiple different queries or sessions. Both of these are fantastic and I would consider best practices. However, they're completely removed from the root problem, the first thing we talked about. If you're using an oversized model, this doesn't help you. You're still going to be overpaying. And that's actually the tricky part because the dashboard doesn't show you which code is responsible for each model call. So you'll just see a heavier model being called and you're not entirely sure if that's appropriate for that task. That's where Frugal comes in. They'll show you exactly which code is calling each respective model and then generate a Frugal fix that'll swap it for the most efficient choice for that task with quantified savings estimate. And that's the missing piece, is the code to cost visibility, because OpenAI will aggregate your spend based on the model, based on the day, based on the usage, but it completely misses the code responsible. So you can't ask which line of code or which component is calling this heavier model. You just see the heavier model spend. You don't even know if you're overspending or if it's the most appropriate model. Without that connection, you're completely blind. And that's where Frugal comes in to bridge the gap between cost and code. They trace every bit of your OpenAI spend to the specific line of code responsible for that call. So what you can do today, actionably, is go into your OpenAI dashboard and see which models you're using most, and then you can use Frugal to analyze your code base alongside with your OpenAI bill. And what they'll do is they'll go through and see if there is a more efficient model, right? Analyze less expensive models to see if they have the same capabilities and optimize your spend there. Then they'll populate a Frugal fix, which generates this change in your code base for you. Hands off, right? So this is how teams are saving money and eliminating wasteful spend without overwhelming their FinOps team or giving their engineers a ton of extra work. The OpenAI billing dashboard is a great place to start, but it leaves you with the aggregate. It tells you what you spent, but it doesn't tell you what you spent it on. And that gap can be extremely expensive and where a lot of opportunities for optimizations get missed, right? Because you can't fix what you can't see. So if you want to connect your OpenAI bill to the code responsible for that spend and you want Frugal fixes generated automatically that propose less expensive, more optimized models with quantified savings. You can book a demo today at frugal.co/book-a-demo or the link in the description. We'll show you exactly which line of code is driving your spend and what you could be saving if you fixed it. Make sure to subscribe for more on eliminating cloud waste in your code base, and we'll see you in the next one.